Now, almost similar, but proportion is much more simple because there will be no condition if n greater than 30, if less than 30, if sigma known or unknown. So there's no such thing if you are dealing with proportion. Okay, because we are dealing with large number of sample size, then everything becomes easy. Okay, so almost similar to what you have in hypothesis testing for the population mean. You are going to have your statement of your hypothesis. So if I take from this particular part, okay, so the first one, if you have two tail tests, then you will have P is equal to P naught. This is your hypothesized value. Hypothesized value. Population proportion. Okay, so alternative P not equal to P naught. Second, H naught P equal to P naught. Alternative P uh, greater than P naught. Or third, null P equal to P naught. Or alternative P less than P naught. So you can imagine where will be the location of the critical value and the rejection region. So in this case, you will have two tail tests. Okay, whereas this is your alpha. Okay, and this is your negative Z alpha over 2. And this is your alpha over 2. Sorry, this is alpha over 2. And this is Z alpha over 2. For this one, okay, for this one, you are talking about right tail test. So this will be your alpha and this is your Z alpha. Okay, and for left tail test, okay, you are talking about left tail test. So this is your alpha and this is your negative Z alpha. So whenever you are dealing with left tail test, don't forget the negative value. Okay, the same goes to two tail test for the left hand side. Okay, so that would be your what we call, these are all the rejection region. Okay, all about rejection region in the shaded area. So in the non-shaded area are all non-rejection region. Okay, the same goes here, the same goes here, non-rejection region. Okay, so what will be the one that differ other than that? The test statistic. The way you calculate the test statistic will be based on this is your sample proportion. Okay, proportion. And this is your hypothesized value. Okay, and these are all using your hypothesized value. So don't mistakenly take this as p hat. So wrong. It should be referring to your p naught, your hypothesized value. And how do I get my p hat? Of course, from this particular what we call formula, x divided by n, as what we have discussed before. Okay, for example, I forgot to copy the questions. Let me stop for a while. Okay, so please refer to your textbook. Example 3.8. Okay, so example 3.8. When working properly, a machine used to make transistor produce 4% defective. Okay, so page okay, so this one is on page, this is
91.
Example 3.8, page 91. Thank you. So what is the situation? When working properly, a machine used to make transistor produce 4% defective. Okay, 4% defective. Now, if this is work properly. Now, whenever the machine produces more than 4 transistors, so if defective more than 4, then the machine needs adjustment. Okay. The quality control department takes a sample of 200. So N 200. Okay. So N 200. And inspect their good, not defective or defective to check whether the machine is working properly. It is found that 14 from 200. So your X equal to 14. From 200 transistors are defective. Take test at 5% significant level. So alpha 5%. Okay. Now, whether or not the machine need adjustment. Now, how do I identify the claim? I'm really sorry, I mistakenly forgot to copy the question. So, how do I know what is my claim? Okay. So, in your textbook as well, it's not mentioned what is your claim. Now, look at the statement. Okay. Okay, so if you are looking at your what we call solution, okay, you will have P equal to 4% and P greater than 4%. Okay, so the quality control take 200 and inspect the defective. So as if there is no such obvious claim. Okay, never mind. Just left for a while, what will be the claim? Now, the first one would be identify what would be your statement. Now, we have your statement, null and alternative. Okay, so since it is not clearly says where is the statement, okay, if you are based on the first sentence, it will be this one as the claim. Okay, but the second sentence says whenever the machine produces more than 4%, which is greater than, as if this is the claim. So if it is a bit confusing, just let's forget about it for a while. Now, second, find the critical value. So the critical value for this particular case proportion will always use the Z. So for Z equal to 0.05, for alpha 0.05, you get 1.6449. Because this is a left field test, it will be positive. Okay, compute the test statistic. Okay, in this case, test statistic is using this particular formula. So if you put everything together and calculate everything correctly, so you get 2.165 as your, what we call your Z value. So if you redraw, okay, so right field test alpha for 0.05. Okay, alpha 0.05. You have your what we call here is 1.6449. And you got your Z value is 2.165. So Z value, okay, is 2.16, which is much larger. So let's say I put it here. Okay, so this is your Z equal to 2.65, which is in the rejection region. Okay, in the rejection region. That's why, okay, fall in the rejection region. So we reject the null hypothesis. Okay, reject null hypothesis. What is your null hypothesis? P is equal to 4%. Okay, reject. Okay, when we reject the null hypothesis, means that we have enough evidence for our alternative hypothesis, P greater than 4%. Okay, so what happens if we reject? The word to conclude will be sufficient or enough evidence to support our claim. So this is what we call common terms used if you have sufficient evidence to support your what we call now alternative hypothesis. So there is enough evidence to support the population proportion of defective transistors is more than 4% at 5 significant level. So the machine needs adjustment. Okay, so that will be the first example. Okay. Are you all still okay? Do you want me to stop here, class? 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 Are you all okay?
Yes, madam.
Class, are you all okay?
Yes, doctor.
Okay, madam.
Okay. Can we do what we call? Can we do one exercise? Then we stop. Is it okay?
All right.
Okay.
Okay,
For those who
madam.
just joined, okay, thank you. For those who just joined, please fill in the Google form for your attendance tonight. Okay. So let us continue with the only one question for the questions. Okay, one question for the exercise. Let us find the easiest one. Okay, let's try number one. A manufacturer of a detergent claims that more than 85% of users satisfied with the detergent effectiveness removing tough stain. Okay, in a sample of 300. Okay, in a sample of 300, 270 user satisfied with the detergent. So N here is 300. Your X is 270. Okay. And then your alpha, okay, it would be difference. What is 85? Okay, see, you can see the claims here. A manufacturer of a detergent claims that more than 85. So here, if I can put, this will be your P is greater than 85. You can put 85% or you can put 0.85. Okay. It's more than, okay. So here, from here, you can have your X, your P hat is equal to 270 divided by 300. So you will get 270 by 300 and 270 divided by 300, you will get 0.9. Okay. So for question 1, okay, determine whether the manufacturer claims can be supported at 1% significant level alpha equal to 0.01. So first step, statement none, so always equal to, so P equal to 0.85. Again, alternative P greater than 0.85. Okay, so where is the claim? The claim is at the alternative. Okay, next, second, we are going to use to find the what we call critical value. Okay, for alpha 0.01, since this is a one-tail test, okay, one-tail test, then Z 0.01 is equal to, let's look at the table, 0.01, alpha 0.01 is 2.3263. 3263. 3263. 3263. Okay, one tail test. So next, find your test statistic. Okay, third test statistic, your Z will be your P hat Okay, that will be 0.9. Okay, P hat minus P naught divided by square root P naught 1 minus P naught divided by N. Is it correct? Okay, divided by N. Then put everything. So P hat is 0.9 minus P naught is 0.85 divided by square root of 0.85 multiply with 0.15 divided by 300. And what is the value here? 0.9 minus 0.85 divided by square root 0.8 multiplied 0.15 divided by 300. Did you get 2.5? Here I get 2.5. Z test. Why mine is Z test 2.5? Almost the same lah, Okay. Let's say just the same. Okay. A bit different, Did anyone calculate and you get different from mine? 0.9 minus 0.85 divided by 0.85. 1 minus 0.85 is 0.15. So 0.9 minus 0.85 divided by square root of 0.85 multiply 0.15 divided by 300. Oh, betul. I got sorry. 2.4254. Okay, more or less lah. So number 4, okay, using p value. If you are using the p value, okay, then I didn't see the question just now. So p value, so no need to use this actually. Okay, if you are using the p value, this one should be the second step. Sorry. Okay, so this one I just quickly rewrite z equal to 0.9 minus 0.85 divided by square root 0.85 multiplied 0.15 divided by 300. We got 2.4254. Okay, then let p value. Okay, p value. Okay, how to get p value? Use 2.4254. Okay, if we were to right tail test, so z is equal to 2.4254, which is this area. Okay, since we know that we need to use the z equal to 0, then we need to find the probability here, which is for z between 0 until 2.4254. Okay, so 2.4254. We look for the z table for the first table. 4254. 4254. 4254. 2.425. 2.5. 2.45. What was the value? 2.4254. 4254. Okay. 4254. Since this is 3 decimal point, right? 2 decimal point. Okay. So 2.43. 2.43 is this one. 0.4925. 4925. 4925. Okay. 4925. So here is 0.4925. So here this will be 0.5 minus 0.4925. This will be 0.5 minus
0.0075.
okay, correct, 0.0075. Okay, so we know that if our alpha is 0.01, so let's check where is the location of our alpha. Let's say I use blue. Alpha is 0.01. Okay, so 0.01 compared to p value here. Okay, so this is the p value. Okay, this one. So where is the location of what we call, is it inside or outside? Okay, so 0.01 with 0.0075. 0.01 is larger than, right? So somewhere here is actually the alpha. 0.01 alpha. So our p value is inside the what we call the rejection region. So then we can decide. Okay, number 4, since okay alpha is larger than p value, okay, then we reject null hypothesis. So number 5, conclusion. Okay, we have, so the claim is at the alternative, then we reject, okay, reject null hypothesis. So we have sufficient evidence to support. We have sufficient evidence to support our claim that, continue with all the sentences, that more than 85%, that more than 85% of the customer, okay, of the customer, of the user, not customer, of the user satisfied, okay, satisfied with the detergent effectiveness, with the detergent effectiveness in removing tough stain. Okay, then